silver chloride. How many grams of sodium chloride and silver nitrate needed for this result? All right, that's a whole lot, right? Gracie, stop it. All right, so student reacts sodium chloride. You know, Na. Okay, let me write this on the paper so we make sure that we do this right. All right. All right, so I got sodium. And if you look at your periodic table, we know that this is a 1 plus and we have chlorine is a 1 minus, right? When you cross those, you get NaCl. Remember, those are the oxidation numbers, okay? And it says with aqueous silver nitrate. Silver is Ag. It is a 1 plus if you look on your chart. Nitrate. So let's look at our polyatomic ion chart. We find nitrate. Nitrate is here. NO3, 1 minus. So you have NO3, 1 minus. We cross these. We get Ag, NO3. So we're taking sodium chloride plus AgNO3. And what are we going to get? We yield, here it says sodium nitrate, okay, and solid silver chloride. So we're going to get Na1 plus, NO3 1 minus. Across these we get NaNO3, and then we get silver chloride, so Ag1 plus, Cl1 minus. We cross these, we get AgCl. So we get NaNO3 plus AgCl. And they're telling us that this is a solid because, remember, if we go back and we look at our solubility rules, okay, anything with chlorine is going to be soluble unless it's silver, lead, or mercury. So sodium chloride is soluble. Silver chloride is not soluble. So look at our nitrates. Anything with nitrate is soluble, so you get NO3 with Ag, and your NO3 with sodium. All of these are soluble. All right. So the type of reaction, obviously, you have these two switch partners, so this is going to be a double displacement, and it's also a precipitation reaction. Okay, and that's because we formed a solid. All right, so that's good so far. Now it says a student produced 15 grams of silver chloride. How many grams of sodium chloride and silver nitrate are needed to make this? So we got to figure out two things. We got to figure out how much, if we have 15 grams of silver chloride, how much sodium chloride and how much silver nitrate were needed to do this, okay? All right. So in order to do this, first thing we do is we say that we have 15 grams of silver chloride, and we need the molar mass. So for every 1 mole of silver chloride, we get what? So there's silver. Silver is 107.868, and chlorine is 35.45. So let's add those together. So we have 107 point, what did I say it was? 868 plus 35.453. All right, and so for this we get 143.321 grams of silver chloride. Next step, you should have this memorized by now, is the ratio. So I go back to my balanced equation. Do we need to balance anything? No, it's fine. Everything's balanced. So for every 1 mole of silver chloride, we get 1 mole of, let's go with sodium chloride. Next step, we got to get to grams, so I need the molar mass. I know that for every 1 mole of sodium chloride, I get 22.99 plus the chlorine, which is 35.453. 99 plus 45.453. And we get 68.443 grams of sodium chloride. Multiply everything on top, divide by everything on the bottom. So if we're multiplying everything on top, we're going to have parentheses 1, 5 times 1 times 1 times 68.443. And we're going to divide this by, open parentheses, 143.321, close parentheses, and we get 7 point, how many sig figs can we have? This is only 2 in 15, so we can only have 2. So 7.2 grams of in a CO. All right. I'm just going to fold this up so we can look at the second problem here. All right, so now the second part says how many grams of silver nitrate. So we're going to start the same way. 15 grams of silver chloride. Guess what? Step is going to be the exact same. For every 1 mole of silver chloride, I get 143.321 grams of silver chloride. Next step, ratio. So I've got grams cancels, moles. So now on bottom I have to have 1 mole of AgCl. And where did I get the 1 from? From the balanced equation. I see right here I have 1 mole of AgCl. So for every 1 mole of AgCl, I get 1 mole of, what am I looking for? Silver nitrate. Sorry, AgNO3. Now, so we went molar mass, we went ratio. Next thing I need is molar mass, and it's for every 1 mole of AgNO3. I'm going to get the mass of it. So silver, 107.868 plus nitrogen, you can't see it, right here, 14.007 plus, how many oxygens? We have 3, so 3 times 15.999. 169.872 grams of AgNO3. So again, we multiply everything on top, divide by everything on bottom. So here we go. 15. What's this? Open parentheses. 15 times 1 times 1 times 169.872. Close parentheses divided by 143.321. And we don't have to worry about anything else. So we get 17.8 grams. And we have to round this to 18s because it can only have 2 sig figs. So it's 18 grams of AgNO3. All right, and the last problem. All right. This is a limiting reactants problem. All right, so on this one, you have 15 grams of aluminum sulfide and you have 10 grams of water. The reactant, so limiting reactant is used up. Here is a balanced equation for the reaction. So, which is the limiting reactant? All right, so the first thing we need to do is you need to start with 15 grams of aluminum sulfide, which is Al2S3. We need to go to moles, so I know for every 1 mole of Al2S3, I have the mass of that. And so aluminum, we look on our periodic table, is 26.982. And there's 2 of those plus 3 times 32.066 because there's 3 sulfurs. We get 150.162 grams of Al2S3. Next step is our ratio. I know for every 1 mole of Al2S3, I get, what am I looking for? Okay, we're looking for 3 moles of H2S. And for every 1 mole of H2S, I have my molar mass. And my molar mass is going to be, sulfur is 32.066 plus 2 times 1.01. I'm going to get a mass of 34.086 grams of H2S. All right, multiply everything on top, divide by everything on bottom. So we're going to say, parentheses, 15 times 3 times 34.086, close parentheses, divided by 150.162, close parentheses, enter, and we get 10 point, how many sig figs can I have? I can have 4. 10.2 you can't see that, grams of H2S. All right, so if we had 15 grams of aluminum sulfide, we would get 10.21 grams of H2S. I can't think of the name of that. All right, next part. I start with 10 grams of H2O. I need to get 2 grams of my dihydrogen sulfide. First step, molar mass. I know for every 1 mole of H2O, I have 1.008, which is hydrogen, times 2, plus 32.066, which is sulfur. Oh, I did that wrong. Sorry. I'm looking for water. Just scratch that. I'm looking for water, right? So I know I have 1.008 times 2 plus 15.999. That's your molar mass of water. So we're going to put 18.015 grams of H2O. All right, so that's my molar mass. Next thing I need is my ratio, so I got to look at my balanced equation for that. We're looking at water, so I know for every 6 moles of H2O, I get 3 moles of H2S. All right. So moles cancel. So I know for every 1 mole, I need the next thing is the molar mass, right, of H2S. I know for every 1 mole of that, I get 34.086 grams of H2S. All right, multiply everything on top, divide by everything on the bottom. So we're going to say 10, well, open parentheses, 10 times 1 times 3 times 34.086, close parentheses, divided by, open parentheses, 18.015, right? Times 6 times 1, close parentheses, and we get 9.460. Yeah, see where that comes from? 9.460, okay? And this would be grams of H2S. All right, so the key here, if we look at this, all right? If we start, pull this back a little bit so you can see. All right. If we start with 15 grams of the aluminum, so here we start with 15 grams of this, we can produce 10 grams, a little over 10 grams of H2S. If we start with 10 grams of water, we can only produce 9 grams of your dihydrogen sulfide. So our limiting reagent, and your limiting reagent, it always has to be, so when I ask for limiting reagent, it's always one of the reactants here, okay? And it's the one that's going to give you the least mass. So the one that we get the least from is when we start with the 10 grams of water. So what is your limiting reagent? Water, okay? What is the maximum mass of H2H which can be formed from these reagents? Well, the maximum that you can get is your 9.460 grams of H2S. That's the maximum amount that we can get. Now the question is, how much excess reagent remains after this is complete? So now this is where you have to think for a second. Okay, this is the total that I could make, right? This is the most I can make, but we can only make 9.46 because of our limiting reagent, right? So let's say 10.21 minus 9.46. Okay, so if I subtract these two, that's going to give me 0.75 grams of H2S. This is the extra amount of H2S that we would have, okay, if we could produce all of and use up all of our reagents. So we have to work backwards from here, okay? So if I know that I have excess, I have 0.75 grams of H2S, right? I need to know how much extra aluminum sulfur, because that's our excess reagent. I need to know how much of that excess I have, okay? So I know that for every, and this we're going to use our molar mass here, so I know that for every 34.086 grams of H2S, that's 1 mole. And I know for every 1, is it 1? No. This is my ratio. So I know for every 3 moles of H2S, I get 1 mole of Al2S3. And I know for every 1 mole, this is now our molar mass, right? Because we're at moles, we need these grams. I know for every 1 mole of Al2S3, I have a mass of, let me go back to this top part here, which was 150.162 grams. And this is of Al2S3. All right. So we take open parentheses. Gracie, Lord. 0.75 times 1 times 1, go across the top, times 150.162, close parentheses. And I'm going to divide this by open parentheses. 34.086 times 3, close parentheses. And I get I write this here, 1.10 grams. Let me write this. I'll write this right down here. Crap. All right, so what I'm getting is 1.101 grams of Al2S3, and that is your excess of your aluminum sulfate. Okay, are we good? I hope so. If you have any questions, come see us. We'll be more than happy to answer any of them.